Hello everyone. So the next concept is unit hydrographs of different durations. So we already know what is unit hydrograph. Now we have to derive a unit hydrograph for a different durations. So you can see here. Now the unit hydrographs are derived from the known unit hydrographs of d durations, and basically the two methods to analyze this. That is. Method of superposition, and the second one is the S curve method. Okay, now you can see here, this is the method of superposition. You can see here the first graph indicates, okay, this first, it starts at 0 and ends here. So this is the first unit hydrograph. So to say day 1, so in day 1 it is 1 centimeter. Okay, duration is 1 centimeter throughout, but it is at day 1. Similarly, you can see here day, this is D, 2D, 3D. Okay, so at D it is 1 centimeter. Second day is, it's also 1 centimeter. So 1 centimeter is constant. That means it is a unit hydrograph. Unit means 1, hydrograph means discharge. So it is a unit discharge. All right. So now we are going to club this. When you club this, we know the unit hydrograph is kept constant. That is, 1 centimeter is kept constant, and it is constant at every day. That is day 1, day 2, day 3. Okay, so when you add of all of this here, day 1, day 2, day 3. Okay, so it is d hour. D hour means it is at every day. Now this d could be 1 day, or it could be 1 hour, 2 hours, 3 hours, anything as such. So it is dr unit hydrograph. So when you club them, you can see here, first day it starts and end. Okay, second day it will start, second hour, second it starts at D, ends here. Okay, there is a lag here. You can notice here in the graph there is a lag. Now when you add all of these, okay, so that is called as method of superposition. Method of superposition is the one where you are going to add them, we are going to sum up, and then if you add all of these, then you get a graph, this dotted graph. Now this dotted graph, okay, so when you add these, it's a method of superposition. So you get, it's still 1 centimeter rainfall, but this is the hours. So it is like D hours. So when you add this, it is direct runoff of D hours at 3 centimeters. So 1, 2, and 3 centimeter at D, 3D hour. Okay. For example, say this is first hour, 1 hour, 2 hour, 3 hour. So it is 3 hour, and when you add all of these, so it is 3 centimeter. So it is a 3 hour, 3 centimeter rainfall. Okay, that is the hydrograph. Now the same thing, if you draw it here, you can see here. So I'm going to add all of these and show only in one. So it is unit hydrograph. Unit hydrograph means 1 centimeter of 3D, that is 3 hours. 1 centimeter, 3 hours. You can see here, 1 centimeter discharge for 3 hours, and this is for every 1 hour there is 1 centimeter of discharge. Okay, so this is called as a unit hydrograph. This is called as a d hour unit hydrograph, means it is at any given hour you can find out the unit hydrograph. This is a unit hydrograph, that is 1 centimeter is fixed. This is for 3 hours only. Okay, so there are two methods. So one is the method of superposition, this is method of superposition, and next is the S curve method. Again, to find out this S curve method, we'll use a formula and the method. So here in S curve method, it's also called as S curve hydrograph. So you can see here again the same, the discharge versus time. So once you plot the hydrograph, unit hydrograph, okay, so you'll get to know for every centimeter, for every 1 centimeter, we'll go on measuring the values. That is, see, first it is u1, next is u2. Okay, so u2 is nothing but it is you have to add u2 for the same ordinate u2, you should add u1. Likewise for u3, if you want to find u3 ordinate, okay, that is nothing but it is sum of u1 plus u2. The previous two ordinates also should be considered. Similarly, u4 is nothing but u1 plus u2 plus u3. So it is more, it's more like a S curve. That's why it's called as a S hydrograph. Okay, because you're going to add the previous ordinates for the successive ordinates. Okay. Okay, next is the rainfall excess of intensity for SA curve and SB curve. Okay, SA curve is nothing but first we're going to draw the S curve. We're going to use the same concept what you're using here, that is same. U2 will have U1 and U3 will have U1 plus U2. Like this, we'll draw the S curve right from 0 point. Okay, that is called the SA curve. All right. Then after a time lag, okay, say a time lag is of t hours, say again it could be a time lag of 2, 4, 6, any hours. So after that we leave that much time and then we'll again start the S curve. That would be called rainfall excess for SB curve lagged by t hours. So this is lagged by t hours here. Okay, so this is called SB curve. This is called SA curve, which is right from the start from the 0 point or 0 hour. Okay, and it successively increases like this, and after some time lag, that is a time lag of t hours, we'll draw the SB curve. Uh, so ultimately we'll be finding out the uh, curve. You can see at this ordinate SA minus SB. So SA minus SB will give us this ordinate. So SA minus SB divided by T by D. Okay, this is what we'll be calculating. So it is nothing but S curve divided by time duration divided by time, and the time is again divided into uh, duration of the hours. Okay, so it will be more clear when we solve the problem. Of course, there are certain limitations of unit hydrograph, because unit hydrograph, what we're going to assume that the there is a uniform distribution of rainfall throughout the basin, which always fails, and the snow melt runoff cannot be satisfactorily represented here, and if the catchment carries unusual large storage, and if it affects the linear, that's how it affects the linear relationship between storage and discharge. So these are the limitations of unit hydrograph. Okay, so let us solve a problem on this. Okay, so the unit hydrographs of 4 hours unit hydrograph are given in the table below. So 4 hours unit hydrograph is already given. From this, you have to derive the ordinates of a 12 hours unit hydrograph by S-curve method. Okay, so the first column is the time in hours, that is from 0 to 34 hours, and then they've given a 4 hours unit hydrograph. So unit hydrograph, again it will be in, it is a discharge, because it is a discharge, so it is meter cube per second. So 4 hours, again it starts from 0 and ends at 24 hours. 24 hours, so it's a 1 day cycle, and then we need to calculate the S curve. Now, from 4 hours, you need to derive 12 hours unit hydrograph. Okay, so to do this, what we'll do is we'll start from the 4th hour. Okay, so from the 4th hour, so first, see it is 0 to 4. So first and second hour will not be considering, because we want it we want the S curve to start from the 4th hour, because they have already told it's a your ordinate of the 4th hour. Okay, so 4 hours, so 4 hours means at this point. So first two I'm going to leave it blank, and then from 4th hour I'll write the same value, that is 0. Okay, so up to 4th hour means there are three values: 0, 25, 100. So these three are the values we need to keep it constant, because there's nothing changed up to 4 hours. So up to 4 hours, we have to keep it constant. So first two, I'm not going to write, but I'm going to write it from the 4th hour. So from 4th hour, you need to consider three values. Again, three values is because you need to stop at 4 hour. Okay. So same 0, 25, 100. The first three values I'm going to write here: 0, 25, 100. Again, I have to stop it here because it is a 4-hour unit hydrograph. Start at 4 and stop at the 4th value. That is 4-hour hydrograph. So there is only 3 points we'll get: 0, 25, and 100. So I'm going to write it like this one. Okay, after this, now you need to do the calculations. That is, first, start from the previous points here. So the previous point here is here. 160 plus 25 is 185 right here. Next, 190 plus 100 is 290. Next, 170 plus 185, 355. 110, 290, 400. 70 plus 355, 425. Then 30 plus 400, 430. And up to the last point, that is up to 20 plus 425 is 445. 1.5, 445, 446. 0 plus 436 is 436. Okay, and then what we are going to do is we are going to add these last two values here again up to this portion. Again, why is this done? Because we need to get the second value. Okay, all right. So now we'll start the S curve coordinate. Now the S curve coordinate is nothing but it should start from A, means it should always start from the 0 point. Okay, so from the 0 point, and that is 0r. So again, all the values, the same value should be written up to this. That means here 0, 25, 100, 185, 290, 355, 400, up to the last point 436. You should go on writing the values. Okay, then we'll find out the SP curve. Now what they've told us, from 4 hours you need to find the 12 hours. So we'll start from the 12th hour now. So the same values, see these values will start from the 12th hour. So 0, 2, 4, 6, 8, 10. Up to 10 you have to just leave it blank. And from the 12th hour you should start the S curve. So same thing, that is 12th hour, that is 0, 25, 100. The same value should be written here once again. Up to the last point. Actually, according to this 436, 446 is the last point. So write the last point here. Okay. Finally, when you have to calculate the ordinate, the last column, that is SA minus SB divided by T divided by D. Okay. So T is nothing but time lag. So time lag here is 12 hours, because they've asked us to find out from the 4 hour you need to find out 12 hours. So time lag is 12 hours and the duration of the rainfall is 4 hours. So it is for every duration of rainfall here 4 hours. Okay, so T by D is 12 by 4, which is 3. Okay, now what you have to do is, so SA minus SV. So calculate this, SA minus SV. So it is 25 minus 0 divided by 3. 100 minus 0, 33 divided by 3. 185 minus 0 divided by 3. Similarly, up to the last. So 400 minus 0 divided by 3. Go on calculating till the last values. So the last column indicates the ordinates of a 12-hour unit hydrograph. Last ordinate. So this will give us the 12-hour unit hydrograph by the S curve method. Okay, this column is important. Okay, on the same lines, let us solve the next problem, wherein it is they have given the ordinates of a 12-hour unit hydrograph of a basin measured at 2 hours interval and are given below. So derive the ordinates of a 6-hour unit hydrograph by the S curve method. So they have given you 2-hour unit hydrograph, 2-hour unit hydrograph, and you need to calculate the 6-hour unit hydrograph. Okay, so first the time here 0, 2, 4, 6, 8 up to, they've given up to 26 hours, and then the ordinates of a 2-hour unit hydrograph. So the ordinates of a 2-hour unit hydrograph is given here up to this last point. Okay, then we have to first find out the S curve. Now to find out the S curve, what we'll do is, it is a 2-hour. So we'll start with the second hour, and we'll take only up to the values up to the second hours only. So it is 0, 20, okay, 0, 20. So second hour ends here only. So only the first two, I'll start from 0 point. Okay, I'll start with 0 and at second hour. So I'll start writing from this point, because we have to lag it by 2 hours. So 2 hours lag is this. Then up to 2 hours, the ordinates here will be constant. The 0 and 20 would be constant. The same here, 0 and 20 are constant here. Okay, now for this we'll go on adding. Okay, so if these two are constant, next we'll go on adding. 80 plus 20 is 100, 100 plus 120, 100 plus 120 is 220, 220 plus 180 is 400, 400 plus 200, 600, and this should go on up to the last point, up to this values here. That is 1126 plus 0 is 1126. Okay, so now we got the S curve. S curve. Now for this, we have to find out SA curve ordinate. Okay, so SA curve is what the same values. You should start from 0. That is from 0 time. So again, same 0, 20, 100, 220, go on calculating up to the last point here. Okay, and then finally calculate the SB curve. Now the SB curve is nothing but you have to give a lag. There should be a lag of 6 hours. So the lag of 6-hour unit hydrograph, say 0, 2, 4, 6. Okay, exactly from the 6th hour, you should start writing these values. The same again, from the 6th hour, 0 to 20, 100, and go on up to the last value. Okay, so once you get this SA and SP curve, next is SA minus SP divided by T divided by D. So we know the time lag is 6 hours and the duration of rainfall is 2 hours. So it is 6 by 2, that is 3. Again, same thing, that is SA minus SB, that is 20 minus 0 divided by 3, 100 minus 0 divided by 3, 220 minus 0 divided by 3, and this should go on up to the last value. So this is the final 6 hours unit hydrograph by S curve method. Okay, all right, that's all for today. Thank you.